Good evening, everyone. My name is Priya, and I work with Eduinx, and I'm part of the Eduinx. Welcome to the two-day data science workshop organized by our Eduinx. Before we start, I would like to introduce for uh, our trainer for this workshop. So, he's a Mr. Snehashis. He's a group manager and principal consultant at EvalueServe. He has with a strong experience in data science, machine learning, and analytics at like across global clients. He has worked on large scale data projects and has guided many students and professionals in building successful data science careers. We are very happy to have him with us today. And as we have 2 days session, so tomorrow's last half an hour will be having the special career guidance by our co-founder Mr. Gurumurthy. So he'll be covering how to get data science jobs and current market needs, how to build the right roadmap, and what companies expect in the interviews, and IBAC global certification value. So as there are some instructions, I want everyone to be mute throughout the session. Your doubts, queries, everything will be addressed by the trainer by the end of the session. And please stay focused and avoid switching the screens. And all participating today and tomorrow will be receiving an official participation certificate from the Eduinx side by the next week. Thank you once again for all, everyone for joining the session, and we hope these 2 days will give you a strong start to your data science career and for the journey. So now I hand it over to Sneha sir to begin today's session. Thank you all.
Hi, Priya. Thanks for the intro. Just give me 2 minutes. I'm just waiting. There are a few people on the visitor section. Let them also join. Can see a lot of people there. Could you invite them, Priya, before we start? Maybe I'll give 2 minutes to
Yeah,
everyone.
sure, sure. I'll do it. I'll do it.
Yeah. Okay, let's start then. uh, Firstly, thank you everyone for joining today's call. Uh, Today's and tomorrow's session We'll be seeing through first what is data science, what is the need for data science, and what are the primary types of machine learning algorithms. And this would help us to understand that what we are getting into and what is the need for that. So, firstly, I believe one should know why we are getting into this field as a whole. If you are spending time behind one particular course of upskilling yourself, what is the need for upskilling in this particular area? Now, there can be many articles, there can be many things that you might be reading from various places here and there. But the base thing is, if you don't know data science today, in this particular age, in one way or the other, whether you plan to go in a technical field, whether you plan to go in a functional field, any field, your growth would be restricted. You can't grow. So you will have to know what is data science and how to use it in your field. Even though there are many tools coming up, many things are coming up. People who have the capability to understand data science, the machine learning part, and combine it in their area of work are the only people who are being valued right now. And it is across all the domains. Whether it is a computer science domain, because it is computer science, then obviously it will be there. Whether it is a telecom domain, whether it is an energy domain, you name anything, whether it is in highly non-technical fields like HR domain, even there people are expected to know nowadays a level of data science expertise so that they can get information out of the data. Is my voice audible? Can someone please confirm? Maybe in the chat. Anyone? Okay. Okay. Thank you. Thank you, everyone. Thank you, everyone. Thank you. Why I'm emphasizing on the need to learn data science is that it is no longer an option right now whether you have to learn data science or not. It is a must. It is like how we had in 1980s or 1990s where the computers started coming into the market in the IT field and many people were reluctant to use it. People, those who were reluctant to use it, were left behind. People, those who used it and adopted it, grew. Same thing it is now the data science. I believe everyone here are fortunate people that now this is the first phase of data science. So you are moving in a little bit early. This is the phase one. People, those who move in now, will have that early movers advantage because now what is happening is it's a data science field. The data science capability has come up. The infrastructure required to run the data science models is less as compared to 3 4 years back. It has reduced drastically the cost, which means now everyone and most of them can create data science applications. So now everyone is trying to find out a path. Where is data science going to be usefully the most? And that is why it is necessary that now you enter this line. Because once it matures, it stabilizes. That time the number of requirement, the number of people that are required in this field will be much lesser. So if you want to enter the field of data science, it is now is the right time. That is why companies are expanding. They are hiring more and more. There are specific data science companies who are just growing year on year. And every other company which might be any other product based, they are also taking data science people. So the flavor of the market is whether you know data science or not. Later on in this particular process itself, a lot of other maturity will come. Robotics will come, many other things will come. But that time it would have matured a lot. A lot of ways that we were doing before on the coding aspect and the various kind of things, those things are no longer applicable now. There are a lot of models that are now available which will help you in the coding. There are a lot of models which will help you in creating presentations, but they all have one thing in common, that they need data scientists. And it is such a field where you are not restricted to just one domain. By domain, I mean to say whether it is banking, whether it is telecom, just not one sector. Every sector needs it. Every sector. So today you can work in one particular domain, tomorrow you can work in different domain. Your demand will be too much high. That is why they are being paid a lot. So in today's world, data science is the train that is moving from one destination to another. If you miss the train, you will miss the opportunity. Regardless of the experience, if there are any experienced people or if there are any freshers people, regardless of that, you need to know this one. So this is what I'll just open the slide. This is what I was trying to bring up in my first few slides. Like, why data science? Why, when I'm spending my time doesn't come back? Why data? This is what I was trying to say. That if you want to enter, enter now, before it becomes more and more complicated, more and more um, different ways come up. I'll just show you. I thought I'll just show you this one. This is what McKinsey, maybe many of the people have heard it. This is what they're saying, technology trends in 2025. And this is going to go beyond. If you see all of them, one, two, agentic, artificial, robotics, mobility, specific semiconductors, everything has data science in that. Everything. So it's a great that you guys have started thinking on this particular capability or upskilling, because the days of hiring a lot of people, hundreds and hundreds over, are very less right now. But the hiring process is something like, now people want to hire employees who can add value to their existing process. Data science adds value, it creates that impact. If you are earning 10 rupees right now, through the use of data science, you might be earning 13, 14, 15 rupees. If you are saving 9 rupees today, tomorrow you might be, through the data science and optimization, you can be decreasing that expenses to 6 or 7. So it has a direct impact. That is why people who are trained in this particular skills are seen by the employers as people who add value. And if you don't have this, what this leads to is all this, what I'm trying to tell. It will cap your salary ceiling. Because whatever decisions nowadays in the enterprise decision, in the company level, it is happening, it's all data based. If today I have to go to someone and explain to them that something has to be happening like this, or it doesn't have to be happening like this, I will have to show them the data, and I will have to explain them that what it would lead to. For that also I need analytics. Analytics of the numbers, analytics of the business. And if I have that, then I am in a position where it is difficult for anyone in the organization to replace me. So the skill sets that you are trying to gain through data science is also in one way safeguarding your future. That when you become an experienced person in the area of data science, you gain the knowledge along with the business skill set, it will be difficult for your employees to replace you. There will be many tools in the market, but only you will know internally what is happening. And that will give you an edge in the work that you are doing, either as an employee or as a businessman. Sky is the limit in this, and it is going to be there for a long period of time. These things that I am trying to say to you is not something that is my own words. It's being said by various leading bankers, leading consultants. And in one way, what I have seen when, through my own experience of hiring people in various organizations that I have been part of, the value becomes very, very much important. When we hire someone, the value becomes very, very much important. What are they bringing to the table? Is the work going to impact the business that we are trying to sell? If it is impacting the business, then this person which we are looking to hire is a great person to hire. The salary brackets and everything drastically changes. You are no longer treated as equals because you impact the business. So, with this in mind, before I start the data science, I'll just give 5 minutes break for, if anyone has any queries, maybe they can put up in the chat before I start it. Or if anyone has any doubts, like, is there a need to learn data science? So everyone is convinced, clear on the need? Great. So let's start with what we are looking at, the data science. What we'll go through in this particular session today and tomorrow is kind to get a flavor of what it is. Data science basically has, wait, it is basically trying to get informations out of the data. You are trying to find out what sort of information you want that will help you to utilize the data in the right way. And this is not an easy task. This is a very, very much complicated task. Because in the real world, what you understand and what you see is huge amount of data, totally unfiltered. You don't know where to start, where to end. Nowadays, what happens is many people try to go and try to see in the Kaggles and the various other online platforms, trying to take the data from there and trying to understand the data from there. In reality, things are not that simple. In fact, that is the reason why no tools that are available right now with everyone, they are directly used by anyone. There are many data science tools that are available, but when it comes to actual businesses, nothing is being used. It is actually the data scientists who have to sit down and work with the data. That's why sometimes it is called as data science is an art. Trying to get information from the data within a specified period of time. That data can be small data or a huge data. And its applications are huge across many domains: banking, e commerce, manufacturing, Gen AI, telecoms. This is what I was trying to explain, that there are the applications where you can use data science is cross domain. Previously, if someone knew there was a technology called as a mainframe, it is still there, but you basically use in banking and maybe in defense. But this is one technology that is there everywhere. So if you learn this, you can go anywhere you want. It is up to you where you want to choose. There are no restrictions on that. That kind of a flexibility it allows. If you would have chosen something like a mainframe or something, you would have worked in the banking domain or in the defense domain, and that too lot of time in a production support environment where you have to work in the night. But since this is something not like that, here you basically mostly work in the development part. You're not much worried about the production support. You can work cross domains. So that is what I tried to emphasize here. If we go a little bit deeper, where is this data science being used? Just think about the impact it is happening. See, in the banking, fraud detection, credit risk modeling. A data scientist is going to help the banks, telling that, okay, if you are giving this person a loan, it should be given at this much percent interest. Or this person who's coming, he's this He's a high risk, medium risk, or low risk. Now just think the criticality of this thing. How critical your work is. If you say to a person that he is of low risk, but actually a person is of high risk, then there is a chance that the bank may not get its money back. But if you say there is a chance that this person is of high risk, but actually is of low risk, because of which you are asking high interest rate from this particular person, he might go to some other bank and the bank will lose its business. So in both the cases where you are saying it's high but it's actually low, the risk wise, and the vice versa, when you are saying it's a low risk but it's actually high risk, there is loss, and this loss directly impacts the bank or the entity that you are serving. That much critical your work is. It directly impacts the money. There's no indirect thing here, direct impact. E-commerce, everyone from you guys might be using Amazon or Flipkart. They are all running and earning because of data science. What you see in front of your Amazon and what I see is totally different. The prices that you might be seeing and the prices that I might be seeing might also be different. And if we both are using, and if I'm using Amazon, and suppose it is not showing me the things that I like, I might switch to Flipkart. So direct loss of customer for Amazon. So because of the impact it has on the industry, that is why data science people are highly paid. You An industry comprises of, a company comprises of many peoples. But what is the impact that person is creating or that department is creating? Based upon that only the salary and everything gets decided. And because of this impact, that it directly impacts, it is selling basically. I'm able to sell. That is the reason why they are being paid more. And nowadays the new thing has come, the Gen AI and various things. You will see that Gen AI from outside looks very much fancy, but only one actually a data scientist person who knows the flow, he will understand where it is, what it is, how complex it is, and how to make use of it. And if you learn this data science thing, when you go out there, when you go to various conferences and various things, many people you will see that who are using generative AI to solve business problems, but they don't know internally how it is working or how better it can be. That time the inputs that you will give, will make you valuable to them. Maybe you might be a position where they might hire you from those conferences itself if you're that good enough. That is what is the trend right now. All the startups and the various things. So it's a very high impactful area. Fortunately, we are starting to pick up. So it's a right place to right time to start. Else, once the market saturates or there are many people inside it, today if you're competing with 10 people, tomorrow you might be competing with 1,000 people. And that time it becomes tough. So with this slide, I was trying to explain to you how in different fields it gets created. Banking, e-commerce, manufacturing, various stuffs. Now, before I go this, what is basically data science? That we just understood part of collecting data, actionable insights from them. As an overall, how many modules are there? The bigger circle is this. Bigger circle is this. AI. It is in this circle that everything comes. Basically, trying to mimic human intelligence. Within that, there comes a concept of machine learning, neural networks, and generative models. Data science is now everyone is listening, but all the research and everything was mostly done by 1970s or 1980s. But they did not have the computational power or the storage power, and it was very, very much costly. It is only later on when the computational power increased that many things became possible. In the early 2000s, the things that were being done was mostly linear regressions and the various kind of things, logistic regressions. They are things that was there previously as well. But when it further improved, the computational part, the cost part, neural networks started coming into it. What is neural networks? Neural network is nothing but machines trying to mimic human brains. How a human brain acts, the same thing neural networks try to do. Is it new? Invented now? No. It is invented long time back in the 1970s, 80s. That time it is invented, but used now. This neural network only, another fancy word is deep learning. And today that you see throughout the world, Chat GPT, Gemini, Claude, all these things are actually neural networks. They are actually neural networks trained on a large amount of data. It looks so simple right now, right? Like machine learning, where you have all the linear regression, logistic regressions there. Neural net, then the neural network came, and huge neural network became part of generative models. And all of this are basically part of creating artificial intelligence. But at each one of them, there are many models. There are different types of models. Every model has a positive and a negative. When to use what, and how to use them is very, very important. So, when you learn data science, you will get to know how each one of these phases have different models, how to take in the data, how to consume the data, and give it the output. So you will first become master of machine learnings, very simple datas, very simple models. Then you will become masters of neural network. And then you will become masters of, from here you will become masters of generative model. At least you will have the base. But this part is just 20% of the part. Only 20%. The actual part is data. 80% work is on the data. 80% work. You give bad data to your model, you will get bad output. In machine learning lingo, it is called garbage in, garbage out. If you give junk inside, you will get junk outside. And if you get junk outside, then all these problems you will face, where you are not able to predict better. And how do you do that? How do you make sure that your data is very well? You follow some steps. You follow some steps of data preparation. You have to collect the data. You need to make sure that the data is cleaned. You need to prepare the data. You need to do analysis of the data. Which column is related to which other column? Whether it is related by chance, means by luck, or is there actually a dependence? And once you have that, when you have done all this kind of analysis, then you feed that data to your model, and then you make a prediction. But does it end till here? No, it doesn't end. Unlike other technologies in data science, you will be in the forefront, you will be the face to which your client or your business speaks. You will have to speak to the business, tell to them that this is what my findings are. You will have to convince them that what you are telling is actually not right. The data is telling me this much. And I'm confident on that because this is what data is telling me. And when you show the data to them, they might not be able to refute you or cancel your suggestions. So that kind of an exposure you get if you are in this field. Just taking a very naive example, everyone, maybe at least since we are all from India, might be seeing cricket. If you see most of the batsmen who are scoring very high runs are the top order batsmen. They score more runs because they get more balls to play. They get the exposure more. They have more overs to play. Same thing in data science. Not only you will have the technical stuff to go around in different companies, but because of this business interaction that you have, the kind of credits and accolades that comes also increases. Yes, there are risks as well, but there, if you do your work well, then you will get more profit as well. And since you will be new in this field, there will be experienced people to guide you, where everything that you do, every good work that you do will get appreciated because you are dealing directly with the business. You don't have any other person in between stopping you or taking your work from yourself and showcasing that. It is you who is there at the forefront. And which also means that this is one skill set you will have to develop. You will have to learn to speak. Initially, it might be a little bit of a problem, but since you have your data in front of you, you will be able to at least start somewhere. And with experience, you will come to a place where things will become very smooth for you. So, if you see the data science, what happens is it has two steps: data preparation, model training. Data preparation is where you collect the data from various sources. You have Oracle, you have Teradata, various kind of sources. You clean that data, you analyze that data, find out which of the important features are important, then take them, put them in a model, predict it, then make a presentation, present it to the business. So these are the two phases in a data science use case. What are the skill set you require? Just giving a gist of all this, what you are able to see here. Communication we have already discussed. You need statistics. Statistics is the mother, father of data science, if I have to say. If you don't know statistics, you can't be a data scientist. So you need to know statistics. Can it be learned? The good thing, yes, it can be learned. When I say statistics, don't be afraid that I might not be able to learn at all. You will be able to learn, because how much is required, that much is enough to learn. You don't need to learn everything. You don't need to be a statistician. You need to learn few concepts, and you need to understand those concepts. That much you need to understand what it is. There are certain portions of it. When you learn that, then you can understand all the other things. So the first thing that we always start with is the probability, the stats part. Then the data processes, the modeling, different types of modeling, various kind of things like that. Programming we need to know, because what we have thought or what we want to implement, we need to implement it somewhere. And that somewhere is in a Jupyter notebook or in a PyCharm. The language that we use is Python. The language that we use is Python. Previously, there was another language called as R, but now it is being overtaken. So data science specific probability you need to learn, data science specific Python coding you need to learn, and understand in your mindset, you are not coders. You are not coders. You are data scientists, which means for implementing your work, the amount of coding you need to know that only. The rest of the things you can find out from here and there from net, and you can do this. But the steps, and for that cleaning, you need to know that. And this is where you will have to play around with your logical thinking. Everything that is coming for you in a data that you are, the data that you are collecting will not be in columns or in a well good formatted table structure. It will be very dirty data. Like if you are downloading comments from a Facebook without any structure or anything, it will be all put together. Now just think, from there you will have to divide each one of the data. You will have to find out each of the name, age, all these things. So it's a Herculean task, but it is required to be done. So for these kind of things, you need a set of coding skills, a limited set of coding skills. I won't say fully, but a limited set. You're not, like I said, you're not coders. Y- you are data scientists. Your area of expertise is fitting stats on data, or shall I say, preparing the data for model fitting, machine learning model fitting, and optimizing it. So before I go ahead, if anyone has any queries, I'm they can share it. We can discuss. Maybe I'll give 5 minutes for everyone. If they want to collate or think something, we will discuss. Now it is 9:05. If someone wants to take a break, we can take it. Else at 9:10 we'll start. We'll just give a 5 minutes break for everyone. Priya, if you have any, if you're able to see any queries, just let me know because my screen is a little bit less visible. Yeah,
Sure.
yeah, thank you.
No query, sir.
Okay. Okay, let's start. Little bit. I hope my voice is audible. Just let me see. Yeah, it's audible. Little bit going down on, little bit expanding on this first bubble. Let us take our first dive into data science. What are the machine learnings models? In machine learning, you have basically three types of modeling: supervised, unsupervised, reinforced. Supervised is when you know what you're trying to find out from the data. When you know, for example, if I ask you, or if someone asks you to find out, please find which customers are going to leave the company or the bank. I know what I'm looking for. Same thing. If someone asks, if your question is, if your problem statement is, please tell us the customers who are going to buy the product, you know what you are looking forward to in your data. That time it becomes supervised. Unsupervised, when you don't know what to find out in the data, which means you are given huge data set. You see what is there in it, what kind of inputs, what kind of trends you can find out. That becomes unsupervised. Reinforced is when, in a machine learning model which learns from its own mistakes, it is automated learning. Where it is used in mostly robotics. If a robotic dog walks, it hits something, it understands there is an obstacle, and it then learns from it. So the vacuum cleaners, which are the robotic vacuum cleaners and everything, they are learning from this. The Amazon or Flipkart or big e-commerce industries, they are using unsupervised. Your all the data, everything there, it is going there. They have a huge data set. From there, it is learning. Okay, you are a person who basically looks into furnitures. You are a person who basically looks into electronics. You are a person who basically looks into clothing. So, and you are a person who basically spends this much amount of money at what particular time in the month, whether it is starting of the month or ending of the month or middle, all these things it is learning. And based upon that, it is categorizing you. that are you a good customer, are you a medium customer, or is you're a high risk customer, what you are. But that can be anything. So all these use cases are there in currently which every industry is using. The Tesla cars that you are seeing right now, all the Indian cars are also trying to find out, okay, if there is an obstacle in front of me, I need to stop. The car needs to stop. It is also data science. The drones that are flowing around here and there, they are also using data science. Okay, this is, if I go in front, there is an obstacle there. There is a tree that uses advanced machine learning called as computer vision. If you would have seen some time back, there was a market called as I'm not exactly getting the name, but it is Big Bazaar or Big Basket, something where you can take the vegetables and put it. It will identify the product and give you the price of that. Machine learning. Why I'm giving all these examples to you is all these things are nearby you. Your everyday life is getting more and more surrounded by machine learning or data science components, which means that opportunities are coming beside you again and again. It is in front of you. And what we are trying to do is we are trying to catch those opportunities. All these use cases which I am telling is a realistic use case, which is already in there, which is not something it is in future. It is already happening. Now it is up to you whether you want to catch them or not. Like how I was saying, probability. How important is probability? It is the base of everything. The real world on the data, stats being put, and then data being prepared, and then the model gives. The model output is also based upon probability. Whether I'm going to buy or whether I'm not going to buy, it actually works on probability. But there are deep fundamentals to that, which needs more time to understand that. And it has to be learnt in the right sequence so that you can find out the meaning of that. If someone tells you that you can learn data science in 1 hour, 2 hours, 3 hours, it's not possible. There is a minimum number of hours required that has to be given. There is no shortcut to it. It's it's a huge area, but it is worth spending the time in this area. Now, just a little bit going a little bit ahead on the sort of the data that we are trying to deal with, or the first few steps or first few understandings that we need to have as a data scientist. So first is the data. Any information is data for us. Image, audio, text, anything is data for us. Through image, we do computer vision. Through audio, we do speech analysis. Through text, we do natural language processing, the social media accounts and various kind of things, who said what is their sentiment. Numbers, obviously, we have integers, we have floats, we have strings. But at the end of the day, machine learning model are mathematical algorithms, which means anything that we give will have to be converted to numbers. So even though if you go and see the next sorts of data, what are in how more we can divide the data. Continuous data, weight of a person can be continuous, 56.4, 56.8. Anything that can take any value, including decimal, that has no limitations, that is continuous. Discrete data, a discrete data is one which has only specific values, like the number of persons, number of students in the class. It can be 5, 6, 10, 12. It cannot be 5.5, it cannot be 6.6. It has to be something fixed. Now, why we are trying to understand these things? Why these all may look very much small things, but why are we trying to understand this? We are trying to understand this because when we do data science, it is very important to understand the nature of the data. A data from outside might look to me as numbers, but it is actually a category. For example, if I have a column which has 0 and 1 value, 0 says the customer is going to buy, 1 says the customer is not going to buy. So these are actually from outside, it looks like a numbers, but they're actually categories. And when you have categorical data, which means columns with categorical values, city, name, all these things. Someone might belong to Bangalore, someone might belong to Delhi, someone might belong to Maharashtra, all these kind of places. Our machine learning model doesn't know what is Maharashtra, what is Bangalore, what is Delhi, what is Chennai. So there is a need to convert it to some form that my machine learning model knows. That is why we try to understand what is the data type that my model is having, or that my source is there with me. And when you learn all these things, only then you will be able to use your model. So if someone is, for example, I'm telling, is from a very much limited exposure to a technical background, they are more on the functional background. But nowadays, with a lot of tools and everything, and few experiments that are coming up, experimental tools, they might be required to create one output. For example, I'm saying that if there is someone who's working in the HR department, I'm going back to the HR on this particular thing. If there is a need to create a report where a person or the department head wants to see that which persons are going to resign, or there are chances are they are going to resign, and if there is a data science tool there to help them out, internal tools, not outside, internal tool, but the person needs to know how to use that. That just giving their place of working won't work there. It will have to be changed. How to interpret that? So even though there are things there to reduce the workload, the person needs to be little bit technically sound enough on this particular field of data science to be able to use the tool. Because if he or she is not able to, their peers are able to, then they create the same output in a better way and are able to showcase their values more. Therefore, this person, even though the person was very much good in their own field, since they did not knew how to the fundamentals of data science, they are losing out on the opportunities that within the same organization is giving it to them to showcase their work. I am using these sort of examples to just showcase you that how deep the data science has gone right now. It is no longer on the surface, or it is no longer an option. It is a compulsion now. If someone looks to grow and they want to see themselves in 4 5 years at a particular level of successful, being a successful person in the particular industry, then this is one skill set that they should have. They not should, they must have. Anyways, just going ahead. So this we have already discussed. What are the, now it is Python, before it was R. Few other, one more uh, language is there, SQL, which is basically querying the various tables. So that also needs to be learned. And one needs to have a basic understanding of that, or one needs to learn a basic understanding of that. But don't get afraid of all these things. Like I said, you are not coders, you are not DBAs, you are data scientists. Your aim is to become a data scientist. These are some of the modules. I'll use a simple word now that we use in Python. The actual word is libraries that we use. For example, NumPy, Pandas, Matplotlib, Seaborn, Scikit-learn, TensorFlow, SkyPy. Basic ones I've given here. If you see, there are not much because the process is laid down. NumPy is for numerical computing. Pandas is for database manipulations, data manipulations actually. Matplotlib and Seaborn are for visualizations, how good you can showcase your results. Scikit-learn is machine learning library. It will have the machine learning library. TensorFlow, Keras, they are being used in part of neural networks, the advanced form. And SciPy is for stats. In the course of uh, when we learn data science, you will see that step by step introduction has to take place. One can't be before, one can't be other. Else, you won't understand the need for it. I cannot, or no one else cannot explain neural networks first and then make you understand machine learning. There is a complexity wise, it increases because only then you will appreciate what it is doing, else you won't. Just giving again a little bit more on this, like what basically when we try to read the data, where are we trying to read it to? Your data can come from various sources. That data has to be read somewhere. That data generally is read into a data frame. A data frame looks like this, rows and columns. Now in reality, you can have rows and columns. Rows can be of lakhs, columns can be of 100, 200. So your internal storage matters a lot. And will you be getting data this much clean? Never. Never you will get. What to do with the data that is not clean? Even after all the cleaning, you might find a lot of data that is missing or zero that doesn't make sense. So there are steps to deal with that. Similarly, there are a few other things that trying to showcase to you, like the list, few of the components you will be using in your data science data preparation steps. See, when the data comes in, what is the first step? The first step is you need to read the data. Then what you do, you need to prepare the data. When you're preparing the data, you might be facing a lot of issues like duplicate values, many other kind of things. That time, all this kind of components helps you out. You might want to filter the data. You might not want that any particular data should be there in my data frame. Or you might look to see that if my data items belong to this particular set of items, you remove them. That time things like list can help. That time also things like dictionary can help. Dictionary is nothing but a key value pair. Means you have a key, this is a key, and this is the value. Name and the name's value. What is list? List is an empty thing, if you can see here. It can have any values. Numbers, alphabet, alphanumeric, string. It can have any values. Dictionary can be a part of a list can be a part of a dictionary. Means inside a dictionary you can also place a list and give it a name. So these things you will use when trying to prepare a data. Suppose there is some junk data inside. You have a column which is suppose with name and its values are hash 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 hash. You might say that okay, if this particular column has hash values or any other values, delete the row. You can't do that one by one. You have to do it in a programming way. That time you use all these things. And how do you do this in a programming way? The better way of doing that is create functions or self-running modules, codes, self-running module codes. They are efficient. That is the way of coding, and it helps in error identification easily. So these are standards of coding. So functions can be something that you have created, or functions can be something that is default as well. When I say default, which means it has functions like this: print, length, type, max, minimum, apps, range. They are all that are already provided by the Python library. You just need to call them. Why I'm telling all these things is this is a little bit what I'm telling about how we start with the data preparation and everything. Before we try to see a little bit of example on how the coding works, let me also tell you that there are few things that we try to achieve in our data preparation, which is what we tell as data cleaning. There, as part of that, we try to make sure that all the null values, all the duplicate values, they are cleaned off, they are removed from the data set, and they are imputed by the right values that is there. Why do we do that is, if we don't do that, then our data is actually not correct. There are different terms in data science which we call as bias and variance, but I would not introduce that right now. What I would say to you is, if you don't do all this sort of cleaning, whatever output that you are getting may not be representative of the actual population. And when your data is not actually correct, your model output will be also wrong. That is what is basically called as garbage in, garbage out. You have to remove that you have to remove the components of garbage from your data. Let me see if I can showcase you few of the other things. Okay. This is a very simple example that I have tried to showcase. A few of the steps that I was just trying to tell you. Here, what we are doing is we are just reading a data set using the pandas inbuilt library, where we are importing the pandas as PD and we are trying to read it. Then we are trying to see What is the shape and size of it? We are trying to understand the data patterns of it. Once we understand this, then based upon the type we try to go even dig deeper. This is not something that you are trying to do. This is all functions provided. You need to know where to use it. And it is telling you what is the minimum value, what is the maximum value, what is the standard deviation, various kind of things. Then I'm seeing that is there any columns with zero values? The reason I do this particular step first, trying to see how much spread the data is to understand the data from where the data is in the plane. See, in a data science, you might have created something excellent today, but after 3 months, it might not work at all. The data pattern might have changed. Lot of things what was working during the before COVID was not working during COVID because the data patterns were changing. People were not making the same sort of payments. People were not spending that much. So they need to be remodeled. Everything depends how much your data is. It's like if in a class people study or average marks are from 40 till 60. Tomorrow something happens or the market or the examination pattern changes and it reaches from 70 to 80, then the model built on 50 to 60 is not going to work on the model for 70 to 80. So you have to start thinking in that way when you are trying to become a data scientist. So that is why all these kind of steps we do. We drop the duplicates, see if any numbers are there or not, what is the spread of the data, and these kind of steps that we do basically is trying to see how much we are trying to get out of it. What is the kind of information that we are trying to get out of the data. So if you see today what we went through what is the requirement of the why data science is required, what are the different levels of data science. And if you want to go a little bit deeper into generative models, see the significant difference between generative models is the Gen AIs, the word Gen AI that you listen right now. Why that word generative? Generative models are the only models which can create new data. All these old ones are working on the existing data and trying to label them. But generative models can create new data. That is why the word Gen AI. And now that is further getting divided into agents. Agentic AI. Every place it is agentic AI, agentic AI. Types of machine learning. Data types. The languages that we use, these are the things that you might be using it for your own. We'll share this PPT with you once the sessions are over for you to go through this. And if you see the starting, it might look very much simple, but once you put down to the coding aspect, this is a very simple and it is a very known with this data set. But places where you have 120, 130 columns, it won't be that easy. You will have to find which columns to take, which columns to ignore, why to ignore, what is the statistical significance of that to ignore. I just can't ignore it because I want to ignore. There has to be a statistical reasoning behind that. For that, we use what? For that, we use probability. There is a concept called as p-value. We use that. So when you learn to understand these dots, you want to connect these dots one by one. That time you will understand this. Now, if you see here in this particular use case, if suppose I'm trying to predict this species, whether this particular set of input is Iris setosa or Iris versicolor or Iris virgina, it is a supervised machine learning. I know what I'm trying to find out. But if this was not there, I was just given this no problem statement, then it becomes unsupervised. If there was some data missing here, how to impute them? I just can't impute saying average or something like that. I will have to see things which make sense, because any imputation I did, when I say the word impute, it means I am replacing one value with another, which means if any particular column is having null values, for example, if this is a null value, I have to impute this null value with something else. Now, in this case, it is not null, it is 0, but there can be NA not available. How to make sure to impute that? What is the process of doing that? So much so that its nature doesn't change. So, after doing all these things, then we come to the process of machine learning. And it is this part that is your 80% of your part. Then you come to visualizations. This is where the business helps. You will go to the businesses and this will see. But I'll just stop till here. If anyone has any queries, please let me know. Yeah, I'm just taking the questions. Uh, why remove? Is it? Can you little bit expand the question, Narendra? Priya, can you help me with the question? I'm not able to see the full question. Can you? There are two questions I can see. One from Narendra and one from I need about machines to learning. Pooja, can you say again? I'm not able to scroll up. Priya, can you help me with two questions here? Can you read out to me the two questions? Hello.
No question, sir.
No, I can see two questions. That's why I'm asking.
One second, I'll just check. Machine learning over
Over?
something is.
Yep. Could you read that part?
One second, sir. I'm just. Yeah, machine. Pooja Vijayanand. She has texted machine learning overview one time. So she has texted. That's it. Overview.
Okay. And the second question, if someone can say that, Narendra, if you can type it again, because I'm not
Yeah.
able to see the full
Okay.
question.
I'm not able to see it.
Okay. Let me tell you. So kindly send this. Okay. Okay. Fine. We'll surely do puja. We'll be sending it over. I think after tomorrow's session, we'll send it over. But let me uh, first give an overview of, again, the machine learning in a very simple way. Machine learning is a field where you deal with the data and try to predict insights out of the data. As part of this process, there is one step which is regarding only the data preparation, and one step is for model predictions. If you divide this machine learning whole area, one is a traditional machine learning algorithms, one is a neural networks, and the other is the Gen AI, generative artificial intelligence. Generative artificial intelligence is nothing but neural networks trained on a large amount of data. Trained on a large amount of data. And what is neural networks? Neural networks are machine learning algorithms capable of mimicking human thinking. They have components like neurons, dendrites, and synapses. So they are made to mimic human brains. And when this neural network becomes is trained on huge like Wikipedia and various kind of things, that time it becomes generative AI. The capability that generative AI has is it can create new data, which means if you today give it, write a poem, it can create a poem and give it to you. Write a story, it can write a story and give it to you. That is not there, but it can create it. Whatever it has learned, it has created. This is not there in the traditional machine learning algorithms. Like in our class 10, 12, we would have learned linear regression. Linear regression is also considered as a machine learning algorithm. Logistic regression, it's also considered as a machine learning algorithm. Neural networks, which is there to mimic the brains, it it also cannot, it is not designed to create new data. But when the same neural network is trained on huge amount of data, it becomes a chat GPT. It becomes a Gemini, capable of creating new data. You give some inputs, it will create a new web page for you, or sorry, a PPT for you, and it will give it to you. So machine learning, in short, is, if you have to define machine learning, the traditional way of defining machine learning is to able to draw insights from data within a particular period of time. When I say particular period of time, it means that it should not go on and go on and go on in an endless loop. It should end, which means that if there is 10, 15 lines of data and it goes on for 2, 3 hours, that is not acceptable. But if it has lakhs of data, then it goes to 2, 3 hours, it is acceptable. So the time frame is dependent upon the amount of data and your objective. If today I'm driving a car and that has to recognize in front of me there is an obstacle or not, it cannot take a long time to decide. If it takes a long time to decide by that particular period of time, it would have hit the obstacle. So time is also of importance here. That's why even though these algorithms were developed before, they were mostly used now after the computational power increased. Now, I don't know if Narendra, you are there or not. If I'm getting the question, if I'm trying to interpret the question, uh, remove null values is what I believe you were trying to say, or remove some kind of a values that you are trying to say. Uh, Let me showcase you a few things that we do. We first, while trying to prepare the data, we remove duplicates. Duplicates means duplicate rows. We take care of null values, or shall I say not any values, values which are not available. Because if our model is expecting 5 columns as input, then all its columns values needs to have values in them. It cannot have any. So we need to treat these things. Third, there is a concept called as outlier treatment. What is outlier? Outlier is something where if your values are from 1 to 10, suddenly you have a value of 98, 99. This is called as an outlier. We need to treat this value. Remember one thing in machine learning, we always create a generalized model. If someone comes up and tells you my model is 100% correct, then it is definitely 100% wrong. If your model has 100% accuracy, that means it is the model is 100% wrong. When we create a generalized model means the model has learned the trends from the data, but it has not mugged up the data. Like in our school college days, we used to say, our parents used to say to us that understand the data, but don't mug up the text. When you mug up the data, that time you will get 100% accuracy in your testing. So, in order to have this, we remove all these values which are fully extreme, which are not within the range what normally the values are. That's why we do all those things like describe and try to see what is the minimum value, what is the maximum value, what is the range that they are playing with. And suddenly you find a value that is too much high. So we need to remove them. Is this a standard procedure? Yes. But there is also a possibility that instead of removing them, I can replace them with some other value. That call we have to take based upon the data. How many values are like this? If the values is 1 or 2, rows are 1 or 2, we can remove it. If the values are many, then it is better to remove them. Because any call rows you remove, any rows you remove, any rows you remove, you are removing information. You are removing information. Information. Then, once this is done, we try to find out the relationship between the columns.